The sections lie assembled in meticulous detail, the beads waiting for a string. We come to the heart of the drama, the making and burying of the continuous line of pipe. Clean steel is vital to a good weld, and it must be dry. Welding is the core of the whole operation, the most critical single aspect of pipeline construction. Where the welders work, there's the tension of high-powered technique and jealous efficiency. In a pipeline, as in a chain, the weakest link determines the strength of the whole structure. The firing point. The two pipes to be welded together must be perfectly aligned, and an internal pneumatic clamp does this. It has a long control rod which is fed through the oncoming section. The clamp propels itself through the pipe, which has just been welded, and is stopped at the open end and locked into position. The new section, manipulated by a side boom, is moved towards the clamp. The line-up man signals the last adjustments to finish with a separation of 1/16 of an inch between the two pipes. When that critical gap has been set, the clamp locks the two sections rigidly together. Basically, welding is a means of fusing two metals together into a homogeneous mass. In this case, of fusing the molten metal of an electrode with the parent metal of the two sections to be joined. Semi-automatic methods speed up this process, putting more metal and with greater penetration into the joint than conventional methods can achieve. This canopy completely surrounds the pipe, whose open end is also sealed off. And under the canopy, the melting metal from the welding gun is surrounded by a shield of gas, of carbon dioxide, which acts as the flux. The electrode is in the form of wire fed from reels at a constant speed into the nozzle of the gun where it meets the flow of gas. Air movement would disturb the gas jet, hence the protective canopy. This first of a series of welds is known to pipeline men as the stringer bead. It gives the joint strength enough to make it self-supporting. The line-up clamp can be removed and put in position for the next weld. Within 3 minutes of finishing the stringer bead weld, and while the metal is still hot, a second weld has to be made. It's called the hot pass weld, and they make it with conventional electrodes, as they do all the subsequent welding. They make a second hot pass, called the super hot pass, within 10 minutes of the first. The front-line welders make these 3 runs and move on. Each joint is wrapped so that it cools slowly. Teams of filling and capping welders follow up. They make repeated passes round the pipe until the joint is filled. Each weld uses 20 pounds of weld metal. It may need as many as 8 runs. Welding is the heart of the matter of pipeline construction and calls for great skill and experience. And because success or failure lies in the weld, it is most rigorously inspected. Its entire circumference is radiographed in one exposure by putting a panoramic isotope scanner in the middle of the pipe. Lead reference numbers are bound in with the X-ray film holder so that it's easy to tell if any weld is in question. When everything's ready, they take the radioactive head out of its safety carrier and set it in position. Everybody, inside or outside the pipe, gets out of the way of the radiation. The pipeline has to be protected against the chemical action of the soil, and when the pipe left the factory, it had already been given a thick protective coating. The bare joints are now treated, cleaned, primed, wrapped in a layer of fiberglass, and then a layer of felt fixed on with bitumen, insulated against corrosion and the harmful effects of the soil. The sections are joined together now into the one great snake, and they're preparing the bed for it to lie in. This bucket-wheel trencher can, in suitable soil, dig a clean ditch, and it can dig it at the rate of about a mile a day. The ditch here is 9 feet deep, as the indicator wires at the back of the machine show. It's as deep as a farmer wants it to be. The trencher makes easy work of ditch digging and can go much faster than the pipe-laying team. But it is kept close up to them because this is fen subsoil, pouring out to make a neat bank along the edge of the cut, well separated from the valuable topsoil. And the trench in fen subsoil will not stand up for very long. The safest trench is the one just cut. There are occasions when the trencher cannot be used, and then it's back to the dragline. Less elegant, but tougher in a bad patch. Across the fens, they used the dragline wherever the more sophisticated machines could not be used. Slung from its side booms, a great length of the pipeline is ready for burial. But before it's finally committed to the earth, there's one more test. The holiday detector quickly finds out any faults which may have developed in the wrapping during handling. The defect is healed with a plaster of hot bitumen. And now they're ready to begin the delicate business of lowering in. It's complicated. It's a matter of coordination. Teamwork. Experience comes here. The first side booms release their load. Then they leapfrog the others to the head of the column. They take the strain on the new section so that the second side boom section can release its sling. Great skill and fine judgment make the job look easy. And the pipeline is well and truly laid. Not all of it, though. Some was not quite quick enough to beat the treacherous fen soil. This is why they kept the trencher close to the lowering in, so that often the trench was kept completely open only for about 2 hours, and that was sometimes too long. Here the pipeline must wait on the side booms while the grabs clear out the caved-in earth to the exact depth once more.